Hello, game theorists. Today we are still in Chapter 7, looking at mixed strategies. So we had a general procedure earlier. Find expected payoffs, take partial derivatives, set them equal to 0. We also saw in the previous episode that sometimes you get weird things like negative probabilities. Now there's another kind of weirdness that can arise, and I'll show you that in an example. So we'll look at a 3x2 game. Now I'm going to deviate from the book's approach. The book has an approach for 3x2 games, but it doesn't scale up. So your book's approach works for 3x2 games, but only for 3x2 games. You couldn't use it for 4x3 or 5x4, etc. What I'm showing you here does scale up, so you want to use that so you can handle games that are more complex. So let's say we have Jake playing against Yusuf. And they're randomizing with these probabilities. And the game is going to be one we actually saw earlier. We saw this one in those slides about dominance by a mixed strategy. So as you'll recall, we did our best response analysis here. We saw that while Z was never a best response, we could not eliminate Z. Z was not strictly dominated by a mixture. So we had to keep Z in there. So now we're going to analyze this game with the usual procedure, and like I mentioned before, we're going to run into some weirdness with the math. So first I'll find Jake's expected payoffs. So Jake is our row player, and row players' payoffs always come first. He could get 10 if AX occurs. AX happens with probability PA times PX. So Jake plays A with probability PA, Yusuf plays X with probability PX, so PA PX is the probability of this happening. We could be over here. In that case, Jake gets 0, probability PA PY. We could be over here and Jake gets 7 in that case. So that occurs with probability PA times 1 minus PX minus PY. So probability that Jake plays A is PA. Probability that Yusuf plays Z is 1 minus PX minus PY. We could be down here. Jake gets 0 in that case. Oh, there should be 1 minus PA, not PB. 0 times 1 minus PA times PX. So likelihood we're here is 1 minus PA times PX. We could get 10 for Jake, but that happens with probability 1 minus PA times PY. Lastly, Jake could get 5, and the probability of that occurring is 1 minus PA times 1 minus PX minus PY. So some stuff cancels. Let's see if I can simplify any further. So you have 10 PAPX plus 7 PA 1 minus PX minus PY. That canceled out because of the 0. And I'll go expand this one here. So we have a 10 times a 1 times a PY, so 10 PY. I also have a 10 times a minus PA times a PY, so minus 10 PA PY. And let's go and expand these guys. So 5 times, I'll bring that 1 through, 1 minus PX minus PY. Then I'll bring this PA through at each of these terms here. So I get a minus PA. Minus PA times minus PX is plus PA PX. Minus PA times minus PY is plus PA PY. So that's Jake's expected payoff. Now Jake controls PA, so I'll take the partial derivative with respect to PA. So what does that give us? So you have PA here, but it's multiplied by a 10 and a PX. That partial derivative will be 10 times PX. I have PA multiplied by a 7 and that stuff over there, so I get 7 times 1 minus PX minus PY. No PAs over here, so those are all just constants from our point of view, so that derivative is going to be 0. I do have a PA over here. That's multiplied by a minus 10 and a PY, so minus 10 PY. So these guys have no PAs. There's a PA. It's got a minus sign from it, and it's being multiplied by a 5, so that partial derivative is minus 5. Here I've got a PA times a 5 and a PX, so that partial derivative is plus 5 PX. Lastly, I got a PA multiplied by a PY and multiplied by a 5, so that'll be plus 5 PY. So all that is set equal to 0. We're going to do some more simplification. So let's expand that guy. (10px plus 7 minus 7px minus 7py. So I guess distribute a 7 through all these terms here. 0 just goes away, it's a 0. So minus 10py minus 5 plus 5px plus 5py. And all that equals 0. Let's combine like terms. So here I have my px's. And there I have my py's. And I have constants. So plus 10px minus 7px, that'll be 3px. 3px plus 5px is 8px. What's going on with our y's? Minus 7py minus 10py, so minus 17py. plus a 5py, so minus 17 plus 5 is minus 12. Plus 7 minus 5, that'll be plus 2. We can simplify further. These are all divisible by 2, so that becomes 4px minus 6py plus 1 equals 0. So let's hang on to that for now. Now, this game here is not symmetric, so I can't just say symmetry and same is true for Yusuf. We actually have to go work through the math for Yusuf and see what's going on with his probabilities. So let's work through that. Hang on just a moment, need more paper. All right. So what is Yusuf's expected payoff? Yusuf is our calm player, so his payoffs come second. He might get a 0. The probability of that happening is PA times PX. Could get a 10. Probably that is PA times PY. Lastly, could get a 9. Well, that's not lastly, it's still another row. But could get a 9. Probability PA times 1 minus PX minus PY. Could get a 10. Probability of that happening is 1 minus PA times PX. Could get a 0. Probability 1 minus PA times PY. Could get 9. So the probability 1 minus PA times 1 minus PX minus PY. Simplification. Zeros go away. What else can I do? I can start expanding stuff in the parentheses. So 10 PA PY plus 9 PA. So 9 PA times 1 is 9 PA. 9 PA times minus PX is minus 9 PX. Sorry, minus 9 PA PX. 9 PA times minus PY is minus 9 PA PY. This, we have a 10 times a 1 times a PX. So plus 10 PX. 10 times minus PA times PX will be minus 10 PA PX. That canceled. So here I have, so this will be multiplied by that. So I have a 9 times 1 minus. So we'll distribute that 1 through first. So 1 times 1 minus px minus py. Then I distribute through the minus pa. So minus pa times 1 is minus pa. Minus pa times minus px is plus pa px. Minus pa times minus py is plus pa py. Trying to see if I can cancel more stuff here. Yes, I can. So let's expand this one. So 9 times 1, so plus 9. Minus 9px. Minus 9py. Minus 9pa. Plus 9pa-px. Plus 9pa-py. And now we get stuff to cancel. So you have this over here, the minus 9pa-px. Cancels out the plus 9pa-px. Minus 9pa-py. Plus 9pa-py. 9pa. Minus 9pa. Can I do anything else? I guess I can combine these. And that seems like it. So I have 10 pa py, and those guys all cancel. Plus 10 px minus 9 px will be plus px. Minus 10 pa px plus 9 minus 9 py. And that's Yusuf's expected payoff. So now let's take partial derivatives. So which ones do we do? Yusuf controls px and py. So we'll take one partial derivative with respect to px. We'll take the other one with respect to py. No px's here, so that goes away. That's just a px by itself. That partial derivative is 1. Minus 10 pa px, so that partial derivative is minus 10 pa. That's a constant, it goes away. That's a constant, so there's no px's in it, So we treat it like a constant, so that also goes away. So that partial derivative is 0. So if you guys do some reshuffling, 1 equals 10 PA, and that gives us that PA is 1 over 10. Yeah, one more partial derivative to work through. So partial derivative for Yusuf with respect to py. Here we got py multiplied by 10 PA, so that's going to be 10 times PA. No py's there, so that's being treated as a constant, so it just drops out. Still no py's, so that also just will be treated as a constant, so it drops out. That's a constant, goes away. Minus 9 py. Partial derivative minus 9 py with respect to py is minus 9. So we get that. Let's move the 9 over there. 10 PA equals 9. Divide both sides by 10. PA equals 9 over 10. So, I said at the beginning, you can get some weirdness with your math, and here's another example of that. So one equation said PA is 1/10. Other equation said PA is going to be 9/10. Other equation said PA is going to be 9/10. They can't both be true. Something seems odd here. So what's going on? So what we're doing here is Yusuf has more strategies than Jake does. So when we work through the math for Yusuf, that ends up imposing 2 conditions on one variable. Usually that's not going to work out very well. So here's what's going to happen. While Yusuf has 3 strategies, he's not going to use all 3 of them in his mixture. His mixture will only involve 2 out of the 3. So how do we decide on that? We're just going to work through both the possibilities here and see how they turn out. So here are the options to dealing with this dilemma. In the first case, you can set px equal to 0, and then you eliminate this condition here. Alternatively, so if you set px equals 0, what it means intuitively is that we're not going to play x. We're only going to play y and z. So we're only going to use the y and z out of our 3 strategies. The other possibility is that you could set py equals to 0, and that means you're going to get rid of the other condition. You're going to drop the partial derivatives, but the py being 0 constraint. Now, it could also be a case, of course, that you never play z, pz is 0, which means that px plus py, so 1 minus px minus py equal to 0. That's another option. That one, though, is not one you would be worried about. If you do have a case where you never play z, Well, what happens, you work through your math just as normal. It just happened to be a case that px plus y would sum to 1. So that one just kind of happens automatically when it occurs. So you only worry about when is px 0, and you only use these guys, and when is py 0, and you only use these guys. So let's work through those possibilities. So if px is 0, that means we're dropping this, so we're not going to pay attention to that part. We're getting rid of that constraint. We're going to use the other one instead. So it means that this one still applies. We're not dropping that up here, so PA is going to be 9/10. So now you go back to what we had earlier over here. We were doing the math for Jake, and this is what popped out at the end. 4px minus 6py plus 1 equals 0. So we're going to plug in this. So plug in px equals 0. So we have 4 times 0 minus 6py plus 1 equals 0. So 4 times 0 is 0. That's going to drop out. So I have minus 6py plus 1 is 0. So I get 1 equals 6 times py. So that means that 1 over 6 is py. So that worked out nicely. That's case 1. Now we'll verify case 2. So case 2 says we're going to set py equals 0, and we're going to get rid of that condition partial py is 0. So that condition was back over here. So we have these two conditions, and case 2, we're saying we're going to drop the second one here. So we're dropping that one, we're getting rid of it, so we're going to keep the other one instead. And the other condition said PA is going to be 1/10. So what does that kind of mean for us? Let's go back over here. So if we're saying py equals 0 instead of px, here's what happens. That condition becomes 4px minus 6 times 0 plus 1 equals 0. So 6 times 0 is 0, that drops out. 4px plus 1 equals 0. Let's move the 1 over there. 4px equals negative 1. Divide both sides by 4. Get minus 1 over 4. well, that's distressing. Px is a probability. You already know probabilities can't be negative. So case 2 doesn't work. So that means our only Nash equilibrium is with case 1. So let's just write that one out formally. So in this case, we have a 3x2 game and you get a negative probability. That means just that case can just be thrown out if there are no dominated strategies. So to write out our Nash equilibrium, so we had Jake was our rogue player, so Jake was going to play A with probability PA, and we said PA was 9/10 over here. That means B is played with probability 1/10. Use of strategies are X, Y, and Z. X is played with probability PX. PX is 0. Y is played with probability PY. PY is 1/6. Z is played with probability 1 minus PX minus PY. So 1 minus 0 minus 1/6 is 5/6. And that is our Nash equilibrium. This goes back to a point I made earlier in that episode about dominance by a mixed strategy. We said that Z was never best response, but Z was never dominated either. Because Z was never dominated, you could not eliminate it. And that turned out to be some very valid reasoning. Z should not be eliminated because Z is actually played in the Nash equilibrium. So it's a very good reason why I did not eliminate it earlier, because it's something that's actually played a majority of the time by Yusuf. So that should wrap up Chapter 7. Be sure to tune in for our next episode, in which we start Chapter 6. That explores when you start combining sequential games with simultaneous games. In the meantime, take care and stay healthy.